Good morning, Bitcoin, and welcome to day 3 of our live coverage from Paraleni Polis in Prague. We're joined by the guys from Parallel Garden. How's it going, guys?
It's great. Thank you very much.
So tell the people at home, what is Parallel Garden?
All right. Let me introduce our project.
All right.
Parallel Garden simply is an application of principles and values of Paraleni Polis on agriculture and protection of natural resources. So what we are trying to do is to build up the practical solutions such as hydroponic system or use farmbot project to find a way how to do an agriculture in the city independently on public subsidies or to like big extent also to corporate finances, and to create something that could be the basics for independent way of producing your own food. Either you're producing on your own or it can be done by some community in the city, for example.
Now, hydroponics means you grow it without soil. What do you grow the plants in? Just basically, if people haven't heard of hydroponics.
Well, so far we are mostly focused on the leaf vegetables. Also, the technology is kind of specific and vegetables such as tomatoes under the same in the same system. But let's say the harvest is a little bit is quite smaller because it's just not compatible.
Sure.
So far the leafy vegetables. The next step will be the fruit vegetables, and yeah. Also in one system we already saw an attempt to grow some weed.
Because whenever anyone sees an indoor garden, they think right away, oh, fluorescent lights. I know what grows under fluorescent lights, right?
But unfortunately this attempt wasn't very successful. Somehow the seed didn't germinate. I guess they had to germinate the seed first, then transfer it to the system. Then it would be more relevant.
But we appreciate the guerrilla nature of this attempt. It was like someone put it there and leave it there.
Oh, no, it wasn't organized. All right. So I think an organized attempt might have better because, yeah, you have to grow it from a clone or something. There's a whole process there. But right now, it's kind of like a box. I've seen it upstairs, and it has some lights above it, and it looked like it had a microcontroller or a computer. What does that do?
Well, this one in the cafe, it's the first prototype. It's the simplest one we have. It's operated just by the timers, and the computer is placed there to monitor the processes. It basically collects the basic data for growing, such as temperature, substrate moisture, uh, or um, or the light intensity. So this one is sending the data to the cloud, and we can learn about the data that's needed for let's say ideal plant growth. And then we have a similar design box but smaller for 9 plants, and that one already the IoT device is getting the information but also controlling uh, the tools such as lights and these. So basically what we want to do with these systems is to be able to code like automation, for example, to measure how much sunlight comes from the outside, and in real time control the power of the light to work more effectively with the energy. Also the same we are trying in exterior conditions. We have one device connected to the drip irrigation on the field, and basically we want to control the irrigation based on soil moisture. So we are measuring also the consumption of water, and we are expecting to get a nice saving there.
So we talked a little bit about this beforehand. Dan has the problem of underwatering his plants. I have the problem of overwatering his plants. How would this system help us solve those problems?
Well, if you are not looking out for automation, you can use the device that will show you a graph or a table of contents about the moisture of the soil. You will see that maybe if uh, if one of you is overwatering your plants, you will see that the data line is is up at the maximum values. If you're underwatering, you will probably see like large fluctuation from the high moisture to the low, like in extremes. Also, and so basically, what you can do is to attempt to water your plants in a way to keep the line stable, and then you will learn how often to water your plants or whatever. It could work like that.
So it could be like an interactive computer game. The first time it doesn't go so well, the second time better, and the better we get at keeping that line steady, not overwatering, not underwatering, the better our plants would grow.
Is it hooked up to an actual like water supply, or do you just kind of refill like refill the?
It's a closed circuit of water, and we are refilling in most areas because we have some more installations in restaurants, or some of these small experimental boxes are placed at the places of the people who bought it from us, who supported us in our research and development. So we have closed water circuit, and we are not operating with the water connectivity. Yeah, because each space is such different that, and we also want to benefit and we want to enhance also the thing that the system can be completely independent, and it can be also relocated anywhere you want, which is also one of the highest, let's say, values of the thing, is that you get the food of the quality, you know what's inside, and you can have it accessible locally, even within the city. So all the like transport chain is not needed anymore.
So I've seen you have not only just kind of the square one that's upstairs, but also one that was kind of in a shop window. It looks like it was vertical. How does that one work?
Yeah, basically it's a series of channels. Let's say it's a polypropylene pipes.
Yeah,
that are on top of each other, and they're connected through the piping. And basically the water is pumped to the upper one. There is a stable water level kept, and all the excess water runs off to the growing channel underneath, and the water goes back to the reservoir. There we don't grow the plants in any media except of some small cube of it could be rock wool, or some jiffy pot, or paper pot. So the plant then root just in the water.
And would you be able to grow like a tomato there, or would you grow more like a small herb or something in those systems, or is it similar?
You can grow also the fruit vegetables such as strawberries, tomatoes. You probably have to adjust the distance, and maybe if you will put the channels too much apart, then you would have to get stronger light, or light source or something. But it's possible in general, yes.
So if you had a cafe, you could just grow some strawberries right there, and then serve some fresh strawberries in the cafe, all grown right there in the cafe.
Exactly.
That sounds great. And so the idea here is for people to kind of have their own personal farm in their house, or maybe a farm at their business that they would share, or maybe a coffee shop would have a farm, something like that.
Yeah, that's one part of the idea. And it's also very important for us because it's quite easy. It's a smaller scale, let's say lower lower target for us to reach, and to get the technology among the people so they can see it, understand it. uh, they can see the value, and it would be a good way how to raise the awareness, and then maybe together with the public to implement an automated greenhouse in the city or whatever, and proceed and start distributing in the area.
Well, what I like about it is it seems like it takes a lot of the hassle out of farming, because you have to get up every morning and water it. The farmer gets up at the crack of dawn. You have to, hoe the field. You have the dirt, the fertilizer, all this stuff. For like a normal person, you're busy. You got to go to work. This seems more like a coffee machine. It's set, it runs. You put the water in every once in a while. You put the fertilizer in every once in a while. Add some seeds, whatever it is. Has some setup, but if you could generally let it run, and then someday you get some tomatoes, or someday you get some lettuce, it sounds pretty cool, right?
Yeah. So the one you've got on display is kind of probably a unit about, I don't know, 3 foot by 3 foot, something like that. I think, what's the largest sort of unit you've implemented?
So far, we implemented this vertical unit, which is 4 2-meter long growing channels, and it's growing nearly 40 plants. And we also tried to calculate like the cost of the growing and whatever, and also we tried to do the calculation, and we already found out that we can grow one lettuce, even including the manpower, in such a small scale for, let's say, less than €1. So we are expecting that if we manage a larger scale project, we might go even down more lower. So
And maybe that's the thing, that from the beginning, the idea, the core idea was to build the rooftop greenhouse on the top of Paraleni Polis, which is probably the best place, in Czech Republic and Slovakia. And also that would be the first rooftop greenhouse in this area. And so it is great motivation. And also, we didn't mention that it's only open sourced, also how to build a box, and also the hardware and software. So it would be not just the first rooftop greenhouse, but also open source greenhouse with own automated processes. Yeah. So it's great motivation. And these first installations, like in Bitcoin Coffee and the vertical hydroponics, is they are the iterations to get to be able to build the rooftop greenhouse. Yeah, because then you can scale. The vertical hydroponic is already scalable, and you can build, for example, like not just one, but 10, and then you have already like 10 equivalent of 400 lettuces a month. Yeah, so then it's quite nice, and you can start with like a to speak with the community, and peer-to-peer marketing or business and so on.
That's very cool. You could control the software and the hardware, as well as that people could build their own boxes. So if you're watching in another country and you want your own automated little plant growing thing, you can build it. You could build, you could multiply the plants by 2, build a larger one, shrink them by half, build a smaller one. All these options are there because the plans themselves are going to be open sourced.
And also they can learn from each other because the data are open, so they can learn from each other how to optimize the processes and to be better and better, exactly as you said before.
Does it have a camera in it? Does it watch the plants while they grow?
yeah, we are collecting the time lapse.
Yeah.
Also, for one reason, in order to be able to monitor the systems that are distributed within the city, so we can see what's happening, but also to collect the database for some future programming on machine learning and such these functions.
And also time-lapse videos are cool.
Yeah.
Oh yeah,
Plants growing and they wiggle and then the light's over here or it's over there. I always see them. They're great videos.
Usually this is the first marketing of every hydroponics or aquaponics project.
Of course, yeah.
And we wanted to be sure that it's not going to be just our first picture or video.
Yeah.
So it was just third or something like that.
And what's the most adventurous thing you've tried to grow so far, apart from weed?
I think for us it was this. There is 2 actually. One of them was attempt to grow tomatoes under the coffee bar, because in the seed pack there, I guess the seeds were kind of mixed. One of the tomatoes was growing much wilder, and it almost grew up through the bar desk, or it was really large, like really taking a lot of space there. And the other one was our colleague programmer who tried to grow a chokcha, which is some South American climber plant. He placed it in this small box, and it ended up by the ceiling of the room. And so that was quite amazing.
Well, I can tell you from my own plant growing experience, I'd avoid pumpkins. Pumpkins grew so well in our garden, they destroyed everything else in the garden, and we had nothing but pumpkins. No one likes them. They're, other than ornaments at Halloween, like the food of them. I mean, maybe you make a couple of pies. Other than else, anyone eats pumpkin at all. So yeah, and they're vicious. They'll eat everything.
I remember
just-
this situation from my family's parents' garden when I was a kid. It was the same, like everywhere.
Everywhere.
Not just at the field that they were just seated. That they were just everywhere.
Yeah, yeah.
on the garden.
Grass, the house next
Yeah.
door, everywhere. Pumpkins are incredible, but not tasty.
So you're just waiting for Halloween.
Yeah,
Yeah.
that's it. Halloween, you're gonna cash in, sell those jack-o'-lanterns. Big profits, big profits.
Or Starbucks, was it the spiced pumpkin?
Pumpkin spice latte
yeah, that's it,
is
pumpkin
really
spice
popular.
latte.
Everybody's into it, and they don't even. I don't even think it has real pumpkin in it. I think it's a chemical flavor
Oh,
that
right.
they make. It's yeah, Starbucks, of course, and they've got you addicted to it too. So it's very fun, you know, to get that pumpkin spice latte going. But so you guys also mentioned you have a project called FarmBot. Looked like it could plant seeds in a normal farm plot, like outside. What's that project about?
Oh, as you said, it's about planting the seeds as well as about watering them, about taking care of non-wanted vegetable or anything that is simply growing there, because
So
it
it
can
could
kills
tell-
it, it can pushes it under the ground.
Oh,
Once they
so
recognize it, there is something like that using a camera that is actually has special intensity for the green light, and it's meant to be like CNC machine for your vegetable for a crop. So this is an American project, open source one. It's called FarmBot, and we got it from one of our supporters and fans of Enviro Meetup, which is actually the part of our let's say it's one of the principles is community involvement. Sorry. And we are also organizing Enviro Meetups, which are discussions or panels, lectures on
Great,
environmental topics. And one day, a guy came here and said, "Look, I have a farm boat back at home for 2 years, and I didn't have a time to build it up. So, guys, if you want to, I can bring it here and you can have it here." So we did. We built it up. Our friends helped us with other equipment around, and we are testing it right now.
So awesome. It's like a CNC machine. So you have like your big rectangle farm plot. Does it have like a vertical and a horizontal beam so it can move all over
printer,
the
like
space
3D
like
printer
a
sort of.
printer?
Yeah.
Yeah.
Oh, cool.
And it does it to the soil. So no more weeding, no more bending over and planting seeds, no more watering the seeds individually perfectly. The computer can do all that for me.
Yeah, basically yes. I think the project is like it's the product is not finished yet. It's basically some, like, let's say, prototype
Mhm.
that goes through customer development. It's also open sourced,
Nice.
and yeah, so it cannot really solve all the problems you have to grow, such as heat
Mm,
or other things or diseases,
yeah. Yeah.
which is much easier to handle in the hydroponic systems. Uh, but it can do these operations and up to certain quality, and also the people who use it, who build it, they have to program, let's say, the growing regime for the different crops.
Mhm.
And I can imagine that they can collect all this information that's stored in the cloud to generate preset sets of the machine that later, when they will reach the product for general public, there'll be just presets where you just, click, I live in moderate climate, I want to grow beans, whatever.
Sure.
And the machine will just start the maintenance operations on its own.
And it would
These are-
know all the spacing for the plants, how far apart the seeds should be, or how many seeds it should drop. That kind of information could all just be
Exactly.
commuted straight to the computer. Yeah. I'll bet we could get that one to grow weed. Nice and
yeah.
outdoor, big rectangle, no top limit. It looked like the other one might be a little too small, unless the lights could be on a rising scale for that kind of like a corn plant or a cannabis plant or whatever it is. These are bushy, large plants. But definitely that one. And that one also having an outdoor one, having a larger plot, not having like a closet size plot, but having a whole room size. You could grow a lot more food with that one. So that would be much more maybe like a community garden, or people working together, saving their money to buy the farm bot. And then the farm bot does a lot of the work that is either difficult or time consuming or likely for me to screw up, like putting the plants too close together or not watering them at all, these kind of things. So it would take a lot of the human error out of farming or small scale farming. Yeah.
Exactly. Also, I, they are claiming that they have some cooperation with the NASA or whatever, that it might be technology, maybe to the space or whatever.
And we could grow potatoes on Mars.
Yeah, but
Yeah.
also to exclude the human mistake.
Yeah.
Maybe, probably.
Sure.
Who knows?
Well, yeah, if you had a hydroponics lab on the space station or whatever, and somebody screwed it up because they were lazy or they didn't pay attention, it would be a pretty big loss to not being able to make food on the space station. It could be a life-threatening loss. Yeah. So much better to put that in the hands of a computer. And it's great to see it happening right now with the kind of 3D printing or printing metaphor, but eventually it'll all be nanites and little itty bitty crawly computers, and then they'll be all over the place. You just dump some nanites in there and they'll take care of everything.
So as you mentioned, the 3D printing, it's also worth it to mention that it's very nice technology, but many people don't know how to use it because, you simply wouldn't have to have a reason to do.
Yeah.
But once you're building up like such a project, that can be the kind of reason how you can connect those technologies, because suddenly you realize that you'll need some part and it's not there, but it's open source, so we can print it out. And that's what we also did. And I think it might be the way to learn how to use those technologies that are here, but you need some practical project, some target,
something better than making little plastic trinkets or something like that. You think farming, making food is a better application?
Otherwise, you're still printing some dinosaurs or Star Wars
they look
things.
really neat.
Nothing against them, but
no, they're just toys. Yeah. I've seen some phone stands are pretty useful. Phone cases, things like this have a utilitarian value. And then, of course, eventually the key is to have that 3D printer that can print the parts to make the 3D printer. And that's when it gets really good. But go ahead. Sorry, I interrupted.
That's cool idea for sure. To be replicatable, but also you can use it very well in prototyping. It can save you a lot of time and money. Like for example, in our project with hydroponics, we have like 6 or 7 things which are 3D printable. And also when somebody, for example, in America would like to build a hydroponic system, they can just find the place, or maybe he owns already the 3D printer and just 3D print the piece who he needs, and you don't need to buy it, which is unbelievable.
You don't have to ship it all over the world. You guys don't have to have 1,000 of them in a warehouse somewhere. It's just when we need one, we make one. Yeah,
and
I think that's really good.
that was the approach which was like understandable for us, like because at the beginning you don't have the best solution, for the piece. You need iterations. So at the beginning, maybe the first 3D printable piece is not working, but you can start, you can make a few changes, and then it's work like in third iterations. But it saves you so much money, like that is the best way how to prototype. So
well, we can let you do the A/B testing, and then you publish it and share it with the community, and somebody else could A/B test and all this, and then we get a incredible widget that we never could have designed on our own. But together we figured it out.
That's the thing. And when you have demand for 10,000 pieces, then maybe the 3D printing is not the most effective way. But you have the prototype, and then you can scale it with other technologies. So
it's a great way to do the testing.
How to use 3D printers for sure.
Well, it's neat to see these ideas that we usually use when we build software being moved into the real world, like A/B testing. That's a software thing, and having the 3D printer making small, minor changes, testing them, but to do it in the real world for something like farming.
Yeah, but it's actually quite different, I guess, because let's say the open source platforms such as GitHub, whatever, are not really known within the
we need a farm hub. We need 3D printer
farmers or general public or whatever. It's mostly known by programmers.
Sure.
Then one challenge is to figure out how to visualize the source you want to open, how to get it accessible to the people, maybe in what format to share it with the people so they can edit, and in at the last the one of the most difficult thing is to actually make them understand, to make them know the GitHub and these. So we actually have to communicate through all possible channels, also like Facebook, or through regular media uh, such as some reports or interviews.
Mhm.
uh, we need to kind of get the people to us, because they are not used to it, so it's quite a challenge to open sourcing such a thing.
I could see that just generally being a problem with farmers. I picture kind of an older demographic, not really a computer demographic, not a lot of like crypto farmers or these kind of crossovers. And then there's the horrible thing to say that we might just have to wait until the older generation of farmers leaves, and maybe their children, their younger people who are from this internet ready generation, have their phone all the time. They'll probably be ready for this. Whereas the older ones, they don't want a microwave. They don't want the internet. They might really not want this 3D printing, even though it could make their job as farmers easier.
Yeah, it's interesting perspective. Yeah, but uh, Jakub very well mentioned, like about the people, and understanding the technology, but also when you have results and the technology is working, that's the thing, how you can attract people, and also with older generations, you mentioned, like we. I was quite afraid, how they will react about the hydroponics, and it's unnatural.
Robots are going
and
to
so on.
take our jobs.
Yeah, but
yeah.
it's not our experience, I have to
Oh,
say,
excellent.
like that all the people are quite, yeah, they accepting the technology very well, because it's automated, and they have problems with watering, taking care about
Sure.
the system, and then they don't like it. But when you are able to visualize, that it's working, how it's working,
Mhm.
but you have to take care about how you present the technology. They can see the watering. Yeah, you can see the needles there, that's why you can see the watering.
Yeah,
And they
yeah.
say, come on, yeah, that's the thing, but you need to show the presentation. And yeah, we have great reactions from, I don't know, like 70 years old a woman, like,
Yeah,
and
that's
she said it's
fantastic. Yeah, yeah.
unbelievable. I would like to have it like 20 years, like it's shit to
I'll bet it's
water
awesome
my
because
plants every day.
it's a transition to data driven farming.
Yeah.
Where right now you do a lot of things by hand and you can feel it and the soil is good and you have a schedule and everything. But if you really had the little meters, you had the numbers, you could say, oh, we peaked here, we spiked here, not enough nitrogen, whatever it is, they can really work on it and figure it out.
But maybe like yeah, it's a transition, but on the other hand, like we would like to stay parallel, and I think this is the strongest and greatest idea, that what we are actually in very narrowly from a general perspective doing, we are creating a competition, but competition of the whole system, not within the system, but
Yeah.
competition to current system in
Mm.
agriculture, let's say. So also it would be great if people will be still able to grow their own food traditional way,
Mhm.
because there's also some know-how that could be
Sure.
worthy in some
Oh, yeah.
situations. So the best solution for us would be if there will be more ways that could live next to each other,
Yeah, yeah.
and we'll develop and we'll learn from each other, because also we will and want to learn from the mainstream agriculture, from the garden, current urban gardening, current
Yeah,
gardening, that people are like doing back at home. Yeah,
They have all the experience with that and all the tips and the tricks, and there's
They
things
know
the
a lot.
computer doesn't know, and it's just like maybe training a self-driving car. You have to have a bunch of farmers train the running farm.
Yeah. But also, I guess from our perspective, quite important thing is that the people can actually respond a lot. Let's say the farmers or professionals who make living on such things, is that basically already, let's say, the agriculture as an industry is very much let's say monopolized, at least in this country. It's
Sure.
very much subsidized and controlled, and they already, or some of them definitely feel the pressure of all these structures that is influencing their business and they're doing. So maybe if they will see a model that works independently on these things, they might be quite motivated to shift there.
So is there a usage so you could just take the sensory parts and deploy it on a a normal sort of in a normal farm?
Yes, we already did one. One of our implementation is this IoT device that's attached to the regular drip irrigation system, and basically it operates the irrigation based on the data from the soil in real time, and we have also series of water meters that that will help us to calculate the consumption in accordance to so we can compare the other technologies of controlling whatever. So yeah, we are expecting, let's say, if there was a human available to be deployed for this operation of the irrigation system, uh, the the saving could be around like 30% or so. So yeah.
Because the technology is so cheap right now. So this installation was less than $100, like in hardware and sensors, which is unbelievable right
And
now.
it's likely only to get cheaper as electronics have continued to go
Yes,
down,
exactly.
3D printing goes up, all these kind of things. Yeah.
Exactly.
Well, it sounds like a really interesting project. Where can people learn more about it? Get the plans, all that kind of thing, contribute?
Yeah, we definitely would like to invite to our GitHub account.
Mhm.
It's linked also with our colleagues. They're cooperating with us. So our GitHub is Parallel Garden, hydroponics in a box, and it's linked also with guys from Octopus Engine, Octopus Lab,
Mhm.
and there you can find the open source documentation for hardware and software. Yeah, so you are able to build whole hydroponic system in the same way we did. And also we published also the economics of the maintenance and so on, the data to be able to stay on a way to be long term economically in like sustainable. Yeah, that's the way. So this is the main source, and then for sure the Facebook, YouTube, and so on.
Yeah.
So a parallel garden.
I really think sharing the data is a great idea. It's a science experiment. You publish the data, other people can learn from the data. They can publish their data. We can all learn from the data. Just that scientific attitude and bringing that to automated farming is a great idea as well, I think. So, all right. Thanks so much, guys, for the interview. And I look forward to talking. Hopefully next year, you'll have done some more experiments, growing some exciting plants in there. And maybe we can hear about maybe some hemp or something legitimate. Of course.
Well, thank you for having us, and we're looking forward to see you again soon.
All right.
And we will work to show you the rooftop greenhouse next year.
Oh, yeah.
Oh, it'd be
let's
great.
hope.
Maybe
It's
maybe
great
next year we'll
motivation.
do an interview up on the roof.
Yeah,
and,
will be
now,
pleasure.
now it's
we can see
recorded,
robot.
so
Yeah, you got
Yeah.
it.
You should do it.
365 days. You're
Yeah.
on the clock now.
You all are invited. Yeah, watch us, and we are on the way.
Fantastic. Thanks so much, guys.
thank you.
Thank you very much.